So today was the day when I started on a printer. I was a bit lazy, so I didn't really document very much up until now. But the first thing I'm trying to get to work are the stepper motors, specifically the carriage stepper motors. And if we take a look at that, oh, it does kind of work. Very nice. So in terms of hardware, this is just an 80 Mega 8 again. And then down here we have some ULN 2003 Darlington transistor arrays. Those are the original components that were also, these components were also used on the original hardware. So I'm pretty sure they can drive this thing without any problems. So why should I deviate from the original one? If it works, that's fine. Yeah. This thing needs quite a bit of power if we take a look at my lab power supply while this thing's working. Yeah, but since I'll be using the original power supply in the end, I don't have to worry about this for the final product. Now my concern is, do we have slip? And a simple way to test this, well, just by hand, is to hammer a letter onto the paper like this, and then reset and do this a couple times. Let's see. And as we can see, there is some slip. Don't know whether this is when turning around or whether I might also have just wrong startup behavior of my control logic for the steppers, so I'll debug this for a bit. The next stepper is working as well. And here we can see each time I push the button, it advances by one character. And I notice we need to do 2 steps per character, so that's pretty good. Here's a quick demo of the carriage movement. The current firmware simply allows me to move the carriage around freely. Or rather, after reset it will null. Let's show that first. There we go. And now I can use my keyboard to move the carriage. I just implemented an algorithm to simply position the carriage somewhere along the axis, so I can just put in a value and it'll go to that value. So if I push 7 on my computer right now, you can see the carriage will automatically move to that position. 6 is a little left, and if I go 7 it'll go to this location again. Only problem is, my script at the moment, it can show how many steps it took to return to 0. And usually, if I reset, you see it's doing this, carriage left after 700 steps. If I go 500 to the right, and I reset, we get 500 steps. But if I go out, and just move it around a bit more, and hit reset again, sometimes we get, okay, this time it worked, but quite often I get values that are like 702. I think we saw it right at the beginning, 702. We occasionally get those, and I'm not sure where we're slipping. I implemented some delays when flipping the direction, but maybe there's some implementation problem. Maybe I'm skipping a stepper motor cycle or something. After some more tweaking of the code, it seems like I finally managed to get the carriage movement clean and without slipping. So we can now move anywhere. Example number 9, here in the outside. And if we type some characters there, we can, well, it doesn't really show on camera, but we always seem to hit the correct point right over the character we previously printed. So the next step will be the type wheel, I guess. So here's the first print. Again, just written using my demo program, my testing program, which I can position, and now I have a key which forwards the daisy wheel by one character and prints it. So if we do this, we can see the characters being printed. Neat. The next step is to build a table and a C code to translate each ASCII character to a position on the daisy wheel. Nothing big, but that's why I actually needed that function here to print out this in order, so I have absolute positioning and can just write down the numbers easily. Here we go, the setup works properly now. As you can see, prints work now. So the only thing that I did not connect so far is the paper feed stepper and, well, the correction tape as well. But I'm gonna wait with these two until I'm building the real board, because I don't really have any space left here. So yeah, I'm just gonna do it on the real board because I don't need it. I can prove everything. I could check and write all the important code with this setup. Like the paper feed's gonna be trivial compared to the carriage movement and the daisy wheel. So here's an example of a print. So next step will be to maybe clean up the code a bit. There have been some weird bugs, I suppose, that I've run out of memory on the AVR, but that's hopefully due to me using a lot of debugging printfs and stuff, which use a lot of memory, so let's hope that that's the case. And then, of course, build the actual hardware. Like build it on a normal breadboard, not on this.